Hi, in this video, I'm going to talk about what happens when you disable spanning tree and specifically what the issue is with duplicate frames and MAC address table instability. Okay, so first of all, let me just mention, if you do not disable spanning tree on your network, I'm going to talk more about this in another video, but if you do this in a lab setting, it's actually kind of cool. You can actually disable spanning tree on all your switches, create a loop, even with 2 switches, plug in a couple of computers like we have here, and in a matter of just a couple of seconds, you're going to see these all your lights just flashing very quickly. Then they'll go solid green. This is typical behavior on Cisco switches. And then everything will be frozen. Your devices won't be able to communicate. Matter of fact, typing on the keyboard will even be difficult because the CPUs are overwhelmed. Anyway, let's get started here. So we've disabled spanning tree on both switches Mo and Larry. And we have host Con and host Baron. Hope I'm saying that right. These are actually 2 of the people that were the inventors of both TCP and packet switching. Okay, so in this example here, we have 2 connections between switches Mo and switches Larry. Oh, these are old 1900 switches, but it works the same. Okay, we have a connection here on port 1, and we have a connection here on port A. So host Con is going to send a Ethernet frame to host Baron. So what happens is switch Mo learns about this MAC address, the source MAC address, and puts it in its MAC address table. All right. Now this next thing it does is looks at the destination MAC address, which is not in Mo's MAC address table. So it floods it out all ports. In this case, floods it out port 1 and floods it out port A. Okay, because we have spanning tree disabled, switch Larry is going to receive this frame twice. So let's say it first receives it on port 1 and adds that to its MAC address table. Okay. Then it receives it on port A. Well, that's newer information. Might be just, of course, milliseconds later. And says, okay, I've got newer information, so I'll remove the entry on port 1 and add it to port A. So there's the beginning of our instability. Now, what is switch Larry going to do? It's an unknown unicast. So what it's going to do is flood it out all ports. So it just received it on port A. So it thinks that's the latest information. So it's going to flood it out all other ports except the incoming port. So it floods it out, will flood it out all ports, including to host Baron, where it's ultimately supposed to go, but also sends it back to Mo on port 1. So now, as you can see, Mo gets the frame again. And now it says, oh, I've just learned some new information that I had thought this MAC address was on my port 4, but now I just received it on my port 1. That's not good information, is it? But it replaces it because it's newer information. And then it says, oh, okay, I've got to forward the frame. And it's unknown unicast. I don't have it in my MAC address table. I'm talking about the destination MAC address. And it floods it out all ports. Back to Con, the originator of the frame. It doesn't need it, of course. And then back to switch Larry. And then you can see this process just continues. The cycle continues. And this is another issue that will actually bring down your switches. Not just a broadcast, but even unknown unicasts. Okay, so this is why we want to make sure that spanning tree is enabled in our network, because redundancy is good, right? Link goes down, we want to have another link, but one of those links needs to be blocked because we can only have one path from any one switch to any other switch in our Ethernet LAN. Otherwise, we have a loop, and then you can see the issue with unknown unicasts.